Hello class, today we'll be talking about 4.2 exponential functions. So the first thing we want to go through is a couple of rules of exponential functions. We're going to be talking about the product rule. We also will be talking about the quotient rule. We also will talk about the negative exponents. And we also will be looking at the power rule. So the first thing we'll look at is the product rule. So if I have a to the n times a to the m is equal to a to the n plus m. So you add exponents. So same case, if I have a to the n over a to the m, it'll be equal to a to the n minus m. You subtract exponents. Now let's say if I had a raised to the negative m. I could rewrite this as 1 over a to the m. So just keep that in mind. So when I look at the power rule, I got a to the n raised to the m, which this would just be a to the m n times m. Just multiply the what? Exponents. So another case is if I have a over b raised to the n, I can rewrite this as a to the n over b to the n. Just different ways you can rewrite these things. And what if I have a times b raised to the n? I can rewrite this as a to the n times b to the n. Just another ways you can look at these type of problems. So let's look at something else. Let's look at radical notation. And a lot of this stuff is a refresher from previous classes. So if I had the square root or the nth root of a, I can rewrite this as a raised to the 1 over n. So n could be what? Any real number. All right? N is any real number, just like the other ones that you have up there. So what if I had a raised to the m over n, which that is nothing but what? The nth root of a raised to the m. So it depends on how you see it. You can have it any way that you want to have it, which is the same as saying I got the nth root of a raised to the m. You can do it that way. It's all the same meaning. So just keep in mind when you're doing this, you don't want to confuse yourself. So for exponential functions, if a is greater than 0 and a is not equal to 1, then exponential function, or then the exponential function with base A is f of x is equal to a to the x, where a is a number. Now let's look at some examples. So example 1. So our first one, it says if f of x equal to 2 to the x, find each of the following. All right. So for our first one, we have a, and we're looking for f of negative 1. Therefore, if I do f of negative 1, it'd be what? 2 raised to the negative 1, which is equal to 1/2. Part B, it says f of 3. So that just equal to what? 2 to the 3, which is equal to 8. Now I'm going to do this one in a different color, which is C. This one is f of 5 over 2, which this would just be equal to 2 to the 5 over 2, which this is the same thing as writing it which way? The square root of 2 to the 5th. Now, this is basically saying that we got the square root of what? 32, which we can actually reduce this to the square root of 16 times 2, which this is the square root of 16 times the square root of 2, which that's just equal 4 times the square root of 2. So basically, I showed you how to actually do all the steps by hand so you can make sure you get the exact answer. So when you're doing these, just make sure you understand what you're actually doing. So let's look at some stuff. So let's say if I have f of x is equal to 2 to the x. All right. The domain and range. So the domain is from negative infinity to positive infinity. And the range is from 0 to infinity. Now, I'm going to show you a and remember, this is your y, this is your x. We have a point here. Now, this right here would be your 0, 1 point. All right? Because if you put 0 in, you'll get 1. All right? You get 2 to the 0 is equal to 1. All right? Now, if we were to look, we'll have something like this. It's exponential, so it grows. I like to dot it out first, then just draw it. And then you will have, your point here. This will be your negative 1 over a. And then you will have your point here. And that will be your 1a. All right. So, understanding the domain, we just know that the domain goes from negative infinity to positive infinity. The range does what? It's bounded by 0. It's bounded by what? 0. So it goes from 0 to infinity. So we can look at a graph similar to this, but I got f of x is equal to 1/2 x. So what happens with this graph, what happens to this graph, and this is y, this is x, and I'm change the color real quick. All right, and we will still have the point that goes through this way. Now, this one actually goes this direction. All right. Where this would be your what? Your 1 and 1 over a. Right? Well, your 1 and a, 1a. And then this one would be your negative 1 and 1 over a. So you just kind of want to understand what you're actually doing. All right? And you know that this is still your 0, 1. Now, the domain of this one is still from negative infinity to infinity. And the range is still the same. It's from what? 0 to what? Infinity. Now we use parentheses because what? It doesn't touch the line of 0. It doesn't include 0. So keep that in mind. So remember, when you graph these are the shape that this is supposed to be in. All right? So let's look at something. I'm going to go to white. So let's just say if we wanted to graph f of x is equal to negative 2 to the x. So the first thing I like to do is make an x, y chart. All right? So in my XY chart, I usually do negative 2, negative 1, 0, 1, 2, just to give me some good points. So if I did f of negative 2, it's going to equal negative 2 raised to the what? Negative 2. Now, remember, the only thing that's being raised to the negative 2 is 2. Keep that in mind. So therefore, I'm going to have what? This would be what? Negative. And then this does what? This is the same as writing it as 2 to the 1 over 2 to the 2. All right? Which that'll just be what? Negative 1/4. All right? So this is going to be negative 1/4. Now, I'm going to do the same thing with negative 1. It'll be negative 2 raised to the negative 1. And this would just be negative 1/2. Then when I raise anything to the 0, it's going to give me 1. So it's going to give me negative 1 because the negative is going to be in front. Then when I do 1, it's just going to give me what? Negative 2. Then when I just do 2, it'll give me negative 4. So if I were to just, plot these. And this is your x-axis, this is your y. And then I'm going to change colors to graph. I'll do red. Well, I'll do blue. All right. So my first point was what? 0, negative 1. So it'll be here. My next point, and I'm going to do the whole number ones. It's going to be 1, negative 2. So it'll be here. Then it's going to be 2, 4, 2, negative 4, which will be here. Now let's go the other way. It's going to be what? Negative 1.5. So that'll be here. And then we have 2 and negative 1/4. It'll be here. So move this up a little bit. And then I'm going to just go ahead and dot this out. And then I'm going to go ahead and draw it out. So remember there's this point here, that point there, and that point down there. And that's the direction it goes. It reflected across the what? X-axis. Because remember 2 to the x, if we remember correctly, 2 to the x went like this. Two to the x went something like that. Now, of course, these aren't perfect, but you get the point on how to actually graph these things. So let's look at solving these things. So let's look. Solving exponential equations. All righty, let's do this. So it says solve 1/3 raised to x is equal to 81. So the first thing we have to look at what we have is we got 1/3 raised to the x. So I can rewrite this as 3 to the negative 1 raised to the x is equal to 81. Then we just know that it's 3 to the what? Negative x. Now, I know that I can write 81 as a base of 3. So that's 3 to the 4th. Now, if I have an equation that has the same base, different exponents, and they're equal to each other, then that means that the exponents are equal. So if I have a to the m is equal to a to the n, that means that m is equal to n. So therefore, that means that x is equal to 4. So x is just equal to what? -4. That's another property. So just keep that in mind. Now let's look at this problem. So if I got 2 to the x plus 4 is equal to 8 to the x minus 6. Now I'll keep 2 to the x plus 4, but I'll make 8 a base of 3. A base of 2. So it'll be 2 to the third times x minus 6. Therefore, I'm going to have x plus 4 is equal to 3 times x minus 6. And I got x plus 4 is equal to 3x minus 18. And then I'm going to move the 3x to the other side, so it's going to be x minus 3x is equal to negative 18 minus 4. So it's going to be negative 2x is equal to, and I'm going to get negative 22. So x is just equal to 11. So when you're doing these problems, just make sure you understand what you're actually doing. And that is the answer to that one. So let's look. Let's look at this. So we got x to the 4 over 3 is equal to 81. All right? Now, what you can do is, when you're solving these, now you can see you're trying to solve for x. So if I were to raise this to the 1/4 and raise this one to the 1/4, or just taking the 4th root, all right? I know that I would wind up getting what? This would be x to the what? 1/3 is equal to what? Now, when you do the 1/4, it's the 4th root. So you'll get plus or minus 3. So now, to get rid of a cube root, we have to do what? Cube it. And if I cube plus or minus, it stays the same. So therefore, x is equal to plus or minus 27. Now, I know some places they show you can just go ahead and do, you could go ahead and do 3/4. Now, the only reason I didn't do 3/4 because I just wanted to show you have to keep your plus or minus. Because anytime you take the 4th root or the square root of something, you have to keep the plus or minus. So don't mess up your stuff because you don't use your plus or minus. Now, the thing is, in these type of questions, using exponentials, now, it's one thing we start to use this for. We actually start to use it for compound interest. So it's called compound interest. Now, if you're following along on your notes, you'll see about compound interest. It says if P dollars are deposited in an account, paying an annual rate of interest R, compounded paid n times per year. Then after t years, the account will contain $8 according to the formula. A is equal to P times 1 plus R over N raised to the NT. So this is your compound interest formula. Now, for a question. So how we going to use it? So, for an example. All right. So, it says, suppose $1,000 is deposited. Let's correct that right there. It's deposited in an account paying 4% interest per year, compounded quarterly, which is going to be 4 times. Now, before we start this problem, I just want to give you some side stuff. So I'm going to write this in blue. You got different things. You got yearly when it's compounded. And it's talking about your N. All right. Yearly is 1. Then we have semi-annually. That's 2. Then you have quarterly. That's 4. Then you might have, it's a couple, then you can have monthly. That's 12. Weekly is 52. And daily. Now, daily could be 365, just depending. And I'll just put an asterisk, all right? Just depending. So let's get back to the problem. The problem says, also, it says find the amount in the account after 10 years with no withdrawals. All right. And it says how much interest is earned over the 10-year period. Now, let's look at this. So we know, and let's go back to my color. All right. So we know that A is equal to my P. So let's go ahead and put where my P is equal to 1,000. My R is equal to 0.04. My T is equal to 10. And my N is equal to 4. All right. So P is equal to, so A is equal to 1,000 times 1 plus 0.04 over 10 raised to the, well, it should be 4 right here, sorry. 4. And then we got raised to the NT should be 4 times 10. All right. So A is just equal to 1,488 $8.86. Then, to figure out the amount of interest, we have to do our I is equal to A minus P. So therefore, it'd be what? I is equal to 1,488.86 minus my 1,000, which will be equal to $488.86. That's the amount of interest that I've earned. So keep that in mind when you're doing these problems. So if you have any questions about this, make sure you send me an email. So now let's look at something. The value of E. So the value of E, now this is one of them numbers like pi that keeps going. But it starts off 2.71, 82, 8, 18, 28, 45, 9045. So when you look at this, it's one of those numbers that just keeps going. So it just keeps going. Now, on your calculator, you will see it. Now, you may see it you'll see something that says LN, or some people say it's IN, but it's actually LN on your calculators. If you do shift in that, you will get it. Now, we usually just use this for continuous compounding. So continuous compounding. Or I'm going to say compounding continuously. Or I'm going to say continuous compounding. Continuous compounding. All right. So if P dollars are deposited at a rate of a rate of interest R, compounded continuously for T years, the compounded amount A in dollars on the deposit is given by the formula A is equal to P e to the RT. So compound continuous is A is equal to P times E raised to the RT. So make sure you write that down. Now, and then the type of question that we would use this for. Now, and I would say example, and hopefully you are reading along with me. This would be example number 9 on your slides. So it says, suppose that $5,000 is deposited in an account paying 3% interest, compounded continuously for 5 years. For the total amount on the deposit it said find the total amount of deposit at the end of the 5 years. So in this problem, they give us our P, which is 5,000. Then they give us our R, which is our interest rate of 0.03. Then they tell us our T is just equal to 5 years. So now when we plug everything in, we got A is equal to 5,000 times E raised to the 0.03 times 5. When we put that in the calculator, we get A is equal to 5,809.17. So make sure when you put this thing in the calculator, make sure you go ahead and multiply this. Because sometimes when you put it in the calculator, it does not multiply right. So go ahead and multiply that exponent, then use that, write it down, then put it up to that power. So if you got any questions about 4.2, make sure you send me an email or you hit me up with a message through Microsoft Teams.